In this video, we're going to find what's the value of n+1/2 factorial, and n is any non-negative integer. So that means that n is greater than or equal to 0. So let's start with the base case, so that would be n equals 0, leaving us with 1/2 factorial. So now we have to find what 1/2 factorial is. So x factorial is the integral from 0 to infinity of t to the x times e to the minus t dt. So plugging in x equals 1/2, leaving us with 1/2 factorial equals the integral from 0 to infinity t to the 1/2 e to the minus t dt. So now we're going to do a u sub, so let u being equal to t to the 1/2. So that means that t is u squared. Solving for t, so that means that dt is 2u du. Plugging that all in, you get from u equals 0 to u equals infinity. T to the 1/2 is u. E to the minus t is e to the minus u squared. dt is 2u squared, 2u, so we're going to multiply 2u times u, that's 2u squared, and then du. So now we're going to do integration by parts, or DI method. So we're going to pick 2u e to the minus u squared, because that can be integrated, and just pick u. So the integral of u with respect to u is 1, so we're going to do plus minus. And the integral of 2u e to the minus u squared is minus e to the minus u squared. So we're going to multiply those together, and this is still an integral. So this will be negative u e to the minus u squared from 0 to infinity. Then minus minus will be plus integral from 0 to infinity of e to the minus u squared du. Now you can check this limit. As u goes to infinity, this will go to 0 because of the exponential, e to the minus u squared, and then when u goes to 0, it obviously goes to 0. So leaving us with 1/2 factorial is the integral from 0 to infinity. We have u, but we can just call it x, so that would be e to the minus x squared dx. But this is also the integral from 0 to infinity of e to the minus y squared dy. So let's multiply these together, leaving us with 1/2 factorial, whole thing squared, equals the integral from 0 to infinity. I'm going to move the integral to the front, so we have the integral from 0 to infinity, e to the minus x squared, e to the minus y squared, dx dy. But we can combine them into one exponential, leaving us with, I'm going to factor out the negative sign, so that would be x squared plus y squared. So now we're going to say dr d theta, so we're going to say r squared equals x squared plus y squared. This is Calc 3 stuff, so dx dy is r dr d theta. So now we're going to plug all that stuff in. So when x and y are between 0 and infinity, so if you look at a plot, when x goes to 0 to infinity and y goes to 0 to infinity, it's just the first quadrant. So r goes to infinity, and theta, well, that goes from 0 to pi over 2. So that's a 90-degree angle. So this will be the integral, double integral. We have, let's write the r first. So we have r e to the minus r squared dr d theta from dx dy with the r in the front. And theta will go from 0 to pi over 2, like we said, and r will go from 0 to infinity because it's the whole first quadrant. So now we're going to do this integral first. So this will be integral from 0 to pi over 2. So the integral of r e to the minus r squared, so that will be e to the minus r squared divided by, so we want a negative 2r. We have r, so we have to divide by negative 2. Plugging in from 0 to infinity, d theta. Now the negative sign can reverse this order of plugging in, so this will go from, instead of 0 to infinity, it'll be from infinity to 0. E to the minus infinity will go to 0, so we just plug in 0. We leave us with, so we have the integral from 0 to pi over 2. Plugging in 0, you get 1 over 2 d theta. and you can just plug this in, so that'd be 1/2 times the integral of 1 is just the bounds, the bound b minus the bound a, which is just pi over 2, leaving us with pi over 4. So now we have that. So this integral, this 1/2 factorial quantity squared equals pi over 4. And 1/2 factorial is positive, so this will be square root of pi over 2. And how come it's positive? Well, the original is over a positive area, so it's positive. So now we have this. So going back to the beginning, we have 1/2 factorial equals the square root of pi over 2. So n equals 1. We have 1 plus 1/2 is 2 plus 1 over 2, which is 3/2 factorial, which is, so n factorial equals n times n minus 1 factorial. Use that rule. Leaves us with 3/2 times 3/2 minus 1, which is 1/2, which is 3 square root of pi over 2 times 2 from this result. And 2 times 2 is 2 squared. So let's do this again. So n equals 2 will be 5/2 factorial, which is 5/2 times 3/2 factorial. We know the result of 3/2 factorial now. So that's 5 times 3 square root of pi all over 2 times 2 squared, which is 2 cubed. So we're seeing a pattern. So you know how factorial goes? So 5 factorial is 5 times 4 times da 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 times 2 times 1. Well, 5 double factorial goes 5 times 3 times 1. So what we're going to do is rewrite 5 times 3 times 1. There's a times 1 on every one because 1 is times itself. So this will be written as 5 double factorial, but n equals 2, so we can write it as 2 times 2 plus 1 double factorial times the square root of pi all over 2. Well, we have n equals 2, and this is 2 to the third power, so that's 2 plus 1. Okay, so we can do the same thing here. So this will be 2 times 1 plus 1 times the double factorial times the square root of pi all over 2 to the 1 plus 1. And then this one we can write it as 2 times 0 plus 1 double factorial square root of pi all over 2 to the 0 plus 1. So in all, we have n plus 1/2 factorial will be equal to 2n plus 1 double factorial times the square root of pi all over 2 to the n plus 1. And that is the end of the video.